Number 1, for each of the following angles, determine the tangent of theta. So for each of the following angles, determine the tangent of theta. 5 pi over 6. Well, I want the tan of 5 pi over 6. Well, first of all, I hate 5 pi over 6, so I'm going to convert that into degrees. I want degrees divided by pi radians. 180 degrees is pi radians. Pi divided by pi is 1. 180 divided by 6 is 3. 30. 30. So we get 150 degrees. So the tangent of 150 degrees, well, tangent is sine over cosine. The sine of 150 over the cosine of 150. So 150 degrees, let's draw a unit circle. I clearly land in quadrant 2. 150. I have a reference angle of, well, I spun 150. That's 150 degrees. If I keep going, that gives me another 30. Well, sine is positive in quadrant 2, but cosine is negative in quadrant 2, so we want the negative cosine of 30. The sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. They're both over 2, so we get 1 over radical 3. That's fine. If you rationalize the denominator, you get radical 3 over 3. Both of those answers are acceptable, though. Tan of 240. Tan of 240. Well, we're in quadrant 4. So let's spin to not quadrant 4, we're in quadrant 3. If that's 240 degrees, my reference angle there is 60. Because that's 180, I need to spin another 60. So what's the tangent of 60? We're in the third quadrant, so tangent's positive. Tangent's positive in quadrant 3, so I just need to know what's the tangent of 60. Well, that's the sine of 60 over the cosine of 60. Sine of 60 is radical 3 over 2. Cosine is 1, cosine of 60 is 1/2, so we get the square root of 3. The tan of 240 is radical 3. We're in quadrant 3, so it's positive. Theta equals negative pi over 4. Remember, negative angular rotations go clockwise. They start backwards and rotate. Pi over 4 is 45 degrees, so this is a 45-degree angle there. I'm in quadrant 4, so 45 degrees is my reference angle, because that's what I spun backwards. That's that angle in that triangle. Quadrant 4, though, only cosine's positive, because ASTC, cosine is positive, so I need the negative tangent of 45. Negative sine 45 over cosine 45 degrees. They're both square root of 2 over 2, so we get a tangent of negative 1. The tangent of negative pi over 4 is negative 1. And 270, 270 is one of those angles that you have to recognize as being on the unit circle. 270 is down there. Well, what point is that? That's 0, negative 1. Sine over cosine. The tan of 270 is sine over cosine. Y over x. Wait a minute, this is undefined. The tangent of 270 does not exist. This is undefined. 270 is not in the domain of tangent. So that is an undefined output for the tangent of 270. Number 2, explain why tan 90 is undefined using two different arguments. So we know that tan of 90 is sine of 90 over cosine of 90. Because tangent, the way we define the tangent function using similar triangles was sine over cosine. Sine of 90, well, let's make a unit circle. 90 degrees is right here. So this red ray is the point 0, 1. Sine of 90 is your y, 1 over 0. That's why it's undefined. That's one reason why it's undefined, because you end up dividing by 0. The other argument is using slope. Remember that the tangent of an angle is the slope of that ray. Well, the slope of that ray is vertical. That ray is a vertical ray, so the slope is undefined. Slope is undefined for that ray. For the terminal ray, terminal ray So the tangent is undefined. The tangent of 90 is undefined. That's using two different arguments. One using the sine over cosine idea, the other one is using the slope. That tangent of theta is the slope of that ray. If sine of theta is 3/5 and theta is in quadrant 1, I have a quadrant 1 angle. What's the value of tan? Well, sine is opposite over hypotenuse. This is a 3, 4, 5 right triangle. You could also use Pythagorean theorem to find that last side. What's the tangent of theta? The tangent of theta is, tangent is TOA, opposite over adjacent, 3/4. Because we're in quadrant 1, it's positive. If I was in quadrant 2, it would be negative 3/4, but they said we're in quadrant 1, so it's positive 3/4. Make that 4 look nicer. Number 4, using the fact that tan theta equals sine theta over cosine theta, explain why the tangent of theta is negative in quadrant 2. Then create an argument that uses slope. So our first argument, let's use sine of theta over cosine of theta. Well, in quadrant 2, your x values are negative and y is positive. That tells me, this implies that the cosine of theta is negative, because cosine is my x, and the sine of theta is positive, because that's my y's on my unit circle. So we know from third grade, probably third grade, that a positive divided by a negative, if I have a positive value, my sine is positive, divided by a negative value, my cosine theta is negative, we get a negative answer. So tangent is negative because tan is negative, tan of theta is negative because a positive divided by a negative is negative. Using slope, well, we have to remember that the tangent of theta is the slope of the terminal ray. So if I have a terminal ray in quadrant 2, I'm going to actually make a circle. If I have a terminal ray in quadrant 2, what does that look like? Well, my ray looks like that. Any type of ray that I make in quadrant 2 is always going to have a negative slope. The slope of a ray in quadrant 2 is always negative. That's the slope argument. The slope of a ray in quad 2 is always negative. And because the slope of this blue ray here is the tangent of theta will always be negative in quadrant 2. Number 5, use the following diagram to help you explain why tan of negative theta is equal to negative tan theta. Maybe you remember from the beginning of the year that this defines an odd function. F of negative x equals negative f of x. This makes tangent odd. Tangent is an odd function. It has symmetry. The graph of tangent should have symmetry when I rotated 180 degrees about the origin. But let's use the unit circle here to prove that this is true. Theta intersects the unit circle at the point x, y. So Q, the reference angle is still theta, but in quadrant 4, my x's are positive and my y's are negative. So this is the point x comma negative y. So we know the tan of theta is sine over cosine. We know tan of theta is y over x. The tangent of negative theta, well, the tangent of negative theta is still your y value over your x value. But notice that this is negative y over x if I just move that negative out front. Well, what is y over x? That's the tangent of theta. The slope of the green ray is just the opposite of the slope of the blue ray. If this has a slope of 1, that has a slope of negative 1. That has a slope of negative, if this has a slope of 1/2, that has a slope of negative 1/2. Simply because my y value on our y coordinate is now just negative. And that changes the sign of tangent. It's the negative of the tangent of theta. The tan of negative theta, if I input a negative angle, I can just do minus tan of that positive angle. This tells me that tangent is odd. Tangent is an odd function. It is rather odd, but symmetry, the graph of tangent, is odd because it can be rotated 180 degrees about the origin and end up on itself. That's what it means to be an odd function.